Hello and welcome to week 7, lesson 2. In this lesson, we're going to look at similar figures and how proportions fit into those. And similar figures are the same shape, but maybe different size, like these puppies here. The mom and the baby look very, very similar in size or in shape, but size is different. Okay, so by the end of this lesson, I'm hoping that you'll be able to find missing lengths in similar figures. So again, said this already, similar figures have the same shape, but not necessarily the same size. Proportions are used to find those missing measurements in similar figures. So here's an example. These two triangles are similar. I'm going to tell you that. So what can we do if we have a missing side? You see it right there. AC is a missing length. We can use this and set up a proportion to solve for X. So we'll take a look. Well, if I look at BC, do you see how I have BC here? The corresponding side or the matching side on the smaller triangle is EF. So if I want to find X, I put the larger triangle on the numerator and I put the smaller triangle in the denominator. So my missing side is on the larger triangle, so it's going to go on top. So AC or X is going to go on top. And then the corresponding or matching side on the smaller triangle is going to go on the bottom. So DF is going to go on the bottom. So now I can replace those sides there with the numbers. So BC was 16, EF was 12, AC was X, and DF was 18. Now we can do our cross product property to solve this. 16 times 18 equals 12 times X. 16 times 18 is 288. Divided by 12, I get X equals 24. So I know my missing side length is 24. All right, so another example of how we can apply similarity. What this picture is showing is there's a shadow cast by the sun. So the sun is up kind of like by my face. All right, so the sun is casting a shadow, and that length you're able to measure. So for the tree, the shadow is 15 feet long. For the girl, the shadow is only 3 feet long. Can we use that information to help us find how tall the tree is, knowing that the girl is 5 feet tall? So what we can do is we can set up a proportion that compares the girl's height to the tree's height by using the shadow length. So the girl's shadow length over the tree's shadow, right? Those shadows are coming from the same sun, so we can use that relationship to help us find the height of the tree. So the girl's height was 5. The tree's height we didn't know, so that's where the X goes. The girl's shadow was 3 feet long, while the tree's shadow was 15. And again, we can cross multiply. 5 times 15 equals 3 times X. 5 times 15 is 75. Divide by 3, you get X equals 25. So the tree is 25 feet tall. And that's an application of proportions and similarity. Another application would be scale models. So let's say you find a 1 to 144 scale model of the space shuttle on Amazon, but it doesn't list the model's dimensions. You don't know how big if you build this thing, you don't know how big it's going to be. Will it fit on your shelf? Maybe you've got X amount of inches that you have available. Okay. You do know that the actual space shuttle is 122 feet long. So the actual one, obviously that one's not going to fit on your shelf, but the actual space shuttle is 122 feet long. Can you use this math that we're talking about to figure how long the model is? You probably guessed we can. So the model scale is equal to the model length over the actual length. That's what the scale means. So my model scale was 144. The model length is the one that we don't know. That's where our variable is going to go. But we do know the actual length is 122. We can cross multiply, and we can divide 122 by 144, and you get 0.847. Now, that doesn't really make much sense. That's in feet, right? Because the actual space shuttle was 122 feet. So this answer is in feet. Maybe you want to change this to inches. How would we do that? Well, we'd multiply by 12 because there's 12 inches in 1 foot. And when we do that, we get that this model is 10.16 inches long. And then you can make a decision based on knowing how long this model is. That concludes our second lesson in week 7. We'll do one more lesson after this.